Thank you. Thank you for inviting me to speak today. It's a real pleasure and honor. And so today, I want to start with a question. It's really cheesy, and I know you're kind of ready for lunch, but maybe just entertain me for just a moment. I want to ask you, when did you last have tech ignite your mind? When was the last really cool experience? I just saw this robot, and so it's kind of happened for me, but was it when you first saw the iPhone? Or, yeah?
First time I used a Cintiq tablet.
The Cintiq tablet?
Cintiq, the Wacom.
Oh, yeah, totally. Anyone else?
First time I used VR.
First time you used VR, right, yeah. And I had a similar experience. Mine was the first time I saw the augmented reality monocle part of Yelp. I pulled my phone out of my pocket. I was just bored. I was going through all the app's features, and I saw this, and my world exploded because I could see through my phone instead of at my phone. And I thought that was really unique. I thought that this was going to change everything, and computation would never be the same. But I was wrong. It's been 4 years, and not many people are using augmented reality. And there's enough to kind of say, hey, we can do something with this. I know there's a couple speakers talking about the use cases for augmented reality. And I think that that's the major aspect, the major problem of why we are not just looking through things instead of at them today. But I think this picture kind of shows another side of the equation. The look on this baby's face is priceless. This is a scene from a breastfeeding study held at Google, where the mother was wearing Google Glass and her baby is just staring at the camera like, oh, are you serious? What is this? And so I think it's partly because of human perception that we don't adopt augmented reality more. I really admire this gentleman. He is a director of user research at Meta. They're an augmented reality headset company. I do not work for them, but I do admire his work. He has a doctorate in perception. He got from Italy, and he's done postdoctorate work at Stanford. And he said something pretty simple, that perceptual processing is important for augmented reality products. I think that's really key, so I'll say it again. Perceptual processing is key. It's really important for augmented reality products. And so today, I want to talk to you about what that means. I think that there's a lot of gains to be made in perceptual processing. Essentially, to make you better, faster, stronger. Yes, I just quoted Kanye West. Please forgive me. That's probably Daft Punk, I think, came out with that song. So double forgive me for my ignorance. But there's 4 parts of these gains in perceptual processing that I think I'd like to talk about today. And they are attention, feature detection, cortical demagnification, and receptor activation. So let's talk about the first one. I'm going to use a use case for the Hyperloop today. I think that's one of the coolest things in the world. So this use case is a Hyperloop operator. He deals with pretty much autonomous Hyperloop track, and his job is to look at forecasts of earthquakes and other items or issues that could come up throughout the week, and to plan and deploy assets and emergency responses, repairs, all those things that would need to take place. It's very speculative. I could be very wrong about any of this, but I had to design something, so I went with that. So I think about attention as an actuator, as a replacement to the button in many cases, a replacement to UI in many cases. And I say that because there's like an accelerometer on these headsets. There's a gyroscope that's tracking your movement in XYZ axes. And if you factor in position, velocity, and acceleration, and you use machine learning on those outputs to measure the attention of somebody, and also hand tracking where their hands are, I think that you can actually build a UI that's probabilistic in what the user is trying to move. When I say actuate, I mean like that is actuating, whether I'm a robot moving around or a human. Whenever I affect the space around me, that's actuating. And so I think that your attention, where you look, I think that can actually replace some UI. So here, what's happened is there's an alert. It says an earthquake predicted, and it's breaking the 2D plane. We're not working in a screen. We're working with depth, height, size, and there's just a wisp wrapped around this person's hand, and it's enveloping their attention. And so another factor of attention is pre-attention. This is the processing in your eyes and your brain that happens between 200 milliseconds and 250 milliseconds. So this is really good to design for, because if you can get somebody to look at something and understand it really fast, then that's going to be a lot easier for them to use your interface. And this guy, I believe he's out of North Carolina. His name is Dr. Christopher Healy. He's a computer scientist PhD. And he just put some examples together on this website. That's at the end of this slide deck, which I'll put online. And it shows you that on the left, it's easier to see a red dot in the middle of blue dots than it is to see a red dot in the middle of red squares. And that's so basic, right? Like, you could have told me that. You didn't come here to hear that, but it's a very rudimentary example. And there's so many more items like this of pictorial cues when we talk about motion and faces and depth. There's so many aspects of which you could apply pre-attentive design. And so an example of this is if you have a GIS map layer, once the person has given more attention to the alert, this will pop up. You'll see these rings showing you the sensors for the track. And then this is the problematic sensor, the orange one. Now, I made a mistake. I should have done some squares here, so forgive me for the bad design. But you kind of get it pretty quickly. And so that's the concept of pre-attention in augmented reality. The next one is cortical demagnification. And basically, this is saying, hey, how much bandwidth of our brains do we really need to understand an interface? Do we need all of it? Do we need some of it? And so the idea is, if you put your hand out in front of you and you look at your finger, then you have more processing power and bandwidth consumed by observing the details in your finger than by if you extend all 5 fingers out. And that's really important, right? That means that we don't always need to use the same level of detail. If we can offload perceptual processing, then maybe let's do it. So an example of this is, this hand used to be kind of gray, and it's a very abstract. It's got no shape. It does not look like a widget. Now it's gone blue, and I think that what that's doing is saying to your attention, hey, if you want to look here, this is an invitation to do it. And the more you look at a scene or a context, the more it's going to unfold. But if you look away, you know what? That's fine. You can go ahead and do that. So the takeaway is, don't use more than you need to use if your augmented reality headset is really freaking smart. And so finally here, once you've dedicated your attention to the UI, you see, okay, I have the option to select tectonics, and you can do that. So the third part is contextual receptor activation. What I mean is, we have all these cones in our rods in our eyes, and the rods are going to process light and dark and movement. They're not very good at detecting color and detail. The cones are going to do detail. They're going to do a lot of light, but it's more expensive to do that type of processing when you go from your eyes to ganglion cells to your visual cortex. So if you can use the rods, maybe you should. And so what I've done here is I put things that are not so important in blue, and then things that you care more about in green. You can use orange, use red, because it's going to gravitate your attention. But you don't need it. You don't need those colors for the other things. So we just talked about, at a very high level, and I might have made some mistakes, but we just talked about attention, feature detection, correlate magnification, and receptor activation. So why? I mean, this was not a real demo that I showed you. Well, I'm going to build a demo. My friend Tyler Lindell and I were given the opportunity to donate a headset from Meta. Meta is giving the headset to nonprofit, and we get to select that one. And so we thought, what is the coolest use case we can imagine? And we said Hyperloop. And so we actually found some guys who won in a contest, a SpaceX contest to build a Hyperloop pod. And now in August, they're actually going to be shooting this thing on a test track at like upwards of 400 miles per hour. And we were like, sweet, that's awesome, man. So we're going to try to build a Hyperloop operator use case if we can get the headset in time. And we're going to try to apply these designs and these methodologies, and I think we're going to make a lot of mistakes. And so now I want to open up the questions, because I think you guys are the best people at seeing the mistakes that I'm making, and you can ask some critical questions that will make me more informed as we move forward on this thing. So, any ideas? Any critiques?
So I have a question. You talked a little bit about frogs and cones and how one is better at seeing black and white in detail.
Mm-hmm.
So do you consider when you're designing things like not using color because you want people to be able to process detail more quickly?
That's a really good idea. And you know what? You're right. I think Google Glass actually did that now that I think about it. They used a lot of white. Not that I'm endorsing Google Glass, but you make a good point at that. That's something to consider, yeah. Oh, right here.
Related to that is that somewhere down the line you want to consider accessibility when you're using color as well.
Oh, somewhat?
Accessibility.
Oh, for like colorblind, so on and so forth?
Alternate, not just colorblind, but different kinds of colorblind.
Mm-hmm. You know, I hadn't even thought about that. That's a really good point. Yes?
The attention actuator, if you're an operator in a pod moving at 400 miles per hour, how does that impact augmented reality?
Oh, yeah, I forgot to say that they won't be in the pod, but they'll probably be like in a remote place.
Okay.
Yeah, that's a really keen point that you made. And everybody's thinking, lunch. Yeah, any last questions? Yeah?
I don't know a lot about the pods, but it seems to me that driving one pod is one case, but the more complicated case is how we keep track of all of them. Yeah,
that is difficult. It's going to take a lot of thought. So look me up on LinkedIn and send me some of your ideas. We'll mention you.
Okay, no more questions, or is there one last one?
Okay.
No?
Oh, cool.
Okay, thank you so much, Micah.
Thank you.